The next section of functions is domain and range. The domain of a function is all possible values of the independent variable, which is usually the x. The range of a function is all possible values of the dependent variable, which is usually y. Domain and range can be represented in set notation using brackets, inequalities, or words, and there's lots of different ways you can write it and you will see it. So if you see curved brackets or backwards square brackets, like the ones just underneath there, here, then they stand for less than or greater than. So there's a little example at this side, I've just put a star next to it. So in this one, if x is greater than negative infinity and less than 3, we could also write that in these two ways here with curved brackets or backwards square brackets. They all mean the same thing. In an exam, you can write your notation in any of those forms and you will be marked correct. If you see square brackets, then that means less than or equal to and greater than or equal to. So for example, if y is greater than 2 and less than or equal to 6, we put a circle bracket by the 2 because it's just a greater or less than, and then we'd use a square bracket here next to the 6 because it is less than or equal to. Example 1 here, we want to state the domain and range of these functions. So for part A, we need to remember that domain is all possible x values. Now when we're looking at this graph here in part A, you'll see there's an arrow at this edge. I've just circled it in orange. That means it's going to carry on going indefinitely, so it's going all the way to negative infinity. At the other end, you'll see here it's a closed in dot, which means it is stopping at that value and it includes that value, and that value is the 8. So our domain for this one would be that it is going from negative infinity all the way up to and including 8. With infinities and negative infinities, just a quick note, it is always just less than or greater than, not equal to, because negative infinity and infinity don't exist, so we can never actually equal them. Other way you could have written this would have been from negative infinity to 8 and used a curved bracket and then a squared bracket. Now the range is all possible solutions, so our y values. So if we look here, this one, I'm going to circle it in red, is still carrying on up to infinity. So it is going up to the positive infinity at the top. Now the lowest y value is once again down here. The graph doesn't go any lower than that, and that is at negative 2. So our range would be from negative 2 all the way up to infinity. Can write that like that, or we could write it with our brackets, would be a square bracket first and then a curved bracket. Part B, for our domain, you see either end here, there are arrows, so it's going on forever in each direction. So it's going between negative infinity and infinity. Different ways you can write this. Easiest way is that we can just say x is an element of R. So x is any real number, and it can be in this situation. Or you could, if you wanted to, you could write it as from negative infinity to infinity. They mean the same thing. Now the range, we want to look for the highest and lowest y value. So once again, with these arrows here, carrying going upwards, it means our highest y value will be infinity. Our lowest y value though is at this point here. The graph doesn't go any lower than that, which is at negative 1. And it's a closed-in circle, which means it also equals that, so it'll be negative 1 and all the way up to infinity. And you can write it that way, or you could write it once again with your brackets, your choice. Example 2, state the domain and range of these functions. So for A, we've got the function, the square root of x minus 5. So with these ones, sometimes it just comes down to you actually using your brain and understanding what values you can put into a function depending on what it looks like. So with this one here, you have to understand we can't have a negative under a square root sign, which means the smallest value that x can be is 5. Because if it's less than 5, you're going to go into the negatives, where if x was 5, we just get 0, and we can find the square root of 0. So in this situation, x has to be greater than or equal to 5. You can write it that way. Once again, you could do it in brackets. Your choice. And the range of this one, now we have to think about the range. What are the possible outcomes? Now, when we square root something, the smallest outcome we can have is 0. It is possible to have 0 as an answer in this if we do the square root of 0. So in this situation, our y value, or our function, has to be greater than or equal to 0. Remember, it can't be negative when we square root an answer. And also with the range of this one, we don't include the negatives because it is a function. And in a function with a square root, the answers can only be positive because otherwise it will fail the vertical line test. B, 1 on x minus 5, our domain. So what values can we put in for x? The main thing you have to notice here is that you have to remember that you cannot divide by 0. So x can be any number, just not 5, because if x was 5, it would be 5 minus 5, which is 0. So we can write that as x has to be an element of real numbers, which is true, but x cannot equal 5. And then range, what values can we get for our solution? Now, it once again is just understanding a fraction, 1 over something. The only number we can't get as a solution in this situation is 0, because you can't do 1 divided by a number and get 0. So y would also be an element of r, but y could not equal 0. And the last one, C, we've got 1 over the square root of x minus 5. So in this situation, we know that our square root can't be negative, which means that has to be at least a 5. But if we had x as 5, we'd have 5 minus 5, which is the square root of 0, which is 0, which we also can't have. So our domain here has to be where x has to be greater than 5, because we can't have that square root equaling 0. So our x has to be from 5 to infinity. The range of this is also going to be slightly different. Now, remember, with the square root function, we can only have positive solutions. So in this situation, our range would be where y has to be greater than 0. Because once again, we still can't get 0 as a solution, but all our answers will be positive because of the square root. So y will be greater than 0, or you can put that into curly brackets. And that's domain and range.